Hello and welcome to video number 9 of the series Mastering the INCOSE System Engineering Handbook in preparation for the INCOSE System Engineering Professional Exam. Video number 9 covers the integration process, chapter 4.8. My name is Lance Sherry and I will be your tour guide for this short video. The System Engineering Handbook encapsulates all of the lessons learned and best practices for developing complex systems in the presence of complex life cycles. Those set of processes and activities number up to 59 processes and activities that are grouped into 7 groups. This video covers the integration process, which is part of the technical processes. The technical processes form the system engineering V, and the integration process is the process that follows the implementation of the individual components, where they're integrated together to form a complete system. So the way to think about this problem of integration is to recognize that the system is a hierarchy or a collection of component systems. And those component systems are collections of subsystems and sub-subsystems and so on. And all of those have to be integrated together, typically by an organization known as the system integrator or the prime, that takes all of the subsystems and pulls them together, connects them in such a way that they generate a system. The purpose of this video is to answer the questions: what is the purpose of the integration process? What are the outputs and inputs of the integration process? What activities constitute the integration process? And then discuss 8 different ways of integrating systems. According to the SE Handbook, the purpose of the integration process is to synthesize a set of system elements into a realized system that satisfies system requirements, architecture, and design. So to put that in plain language, you're going to take all of the subsystem components and integrate them together such that they yield the overall system that was specified in the requirements by the architecture and the design. The processes are fairly straightforward. You start with the system elements themselves, the description of the elements and their interfaces. Then those are successively integrated into a composite system, a holistic system. And at the end of the day, the output is to have an integrated system. You should note that one of the key elements of the activities is this idea of successively integrating system elements. It's typically not practical to just put all the subsystems together and then turn on the switch and watch it go. So that makes it very difficult to debug the system when it's integrated in such a manner. So there are incremental, successive ways of integrating the components to yield a system that system engineers have developed. The integration strategies and approaches have been defined as 8 methods in the System Engineering Handbook. This is a running list and definition of the 8 methods, and then what follows in subsequent slides is a more detailed description of each one of them. The first one, starting on the upper left, is that of global integration. That's also known colloquially as a Big Bang approach. You just take all of your subsystems, you connect them up, turn on the power, and go. The second approach is the integration with delivery stream. This is the approach where the subsystems will not all be delivered at the same time, and you just accept them based on first come, first serve. Subsystem 1 or component 1 comes in, you test that, component 2 comes in, you test that, you join the 2 together, and you go with the delivery stream. Incremental integration is more of a step-by-step approach that allows the systems to be integrated in an organized, logical manner. And this is true for the remaining items. Kind of each one of them, items 3, 4, 5, 6, 7, and 8, are kind of more thought through, more systematic approaches. So subset integration is an approach where the subsystems are integrated together, and then the subsystems are integrated to form the system, and so on. So a kind of a subsystem-based approach. Number 5 is a top-down integration approach, where you start with the activation, utilization order of the systems and work your way down, integrating them. The bottoms-up integration is you start from the bottom and work your way up. Criteria-driven integration is an interesting strategy to mitigate the project risk, and that is to test the highest risk components first, and to integrate the higher risk component subsystems first in order to have more time to address any issues associated with them. And then number 8 is kind of the theoretician's dream, is to integrate systems with minimal coupling, and that minimizes the requirements for simulation of the components that are not available. So these are the 8 different approaches. Global integration, integration with delivery stream, and then the remaining ones are kind of more strategic, methodical approaches: incremental integration, subset integration, top-down integration, bottom-up integration, criteria-driven integration, and minimal coupling. So let's just take a minute or two and look at each of the individual approaches. The global integration, you throw everything together, you put it into your test facility, you throw inputs at it, you generate the outputs, and you're good to go. In any mildly complex system, this approach makes it very difficult to debug the system, because you don't know what is causing what problems. Keep in mind, when you're doing this integration, the individual suppliers for the system components and subsystems will be updating their software and hardware and making changes. So when you do that in the global integration process, that makes it very difficult to keep track of. The integration with delivery stream, this is an approach where the system is shipped first come, first serve, and then it's integrated into a subsystem. The blue components that are shown here are the simulation that's required to fill in for the missing systems. So there is a tremendous amount of simulation components that are required in order to support this approach. Incremental integration is this idea where you start off with a piece of the system and then add another piece of the system, kind of one at a time, and incrementally increase the functionality and test the system incrementally. So here there's necessary to also simulate the missing components. Subsystem integration is kind of a more system hierarchical way of thinking about it. You take the component systems, you organize into subsystems, you test those. Once you've tested the subsystems, you connect the subsystems together and test those, and so on until you've integrated the overall system. The top-down approach allows you to create the system from the sequence of operations. So typically in this diagram, you would start from the upper left-hand side and work your way down to the lower right. In contrast to the top-down is a bottoms-up approach, where you start off with all the atomic components and work your way up the system. In both of those, the missing components have to be supported by simulation capability. Criterion-driven approach is to address project risk, and this is the idea that you identify the components that have the highest degree of uncertainty related to requirements or other issues, and get those tested as soon as possible. And then, of course, this approach requires a lot of simulation to fill in the missing pieces of the overall system. So strategy number 8 for minimal coupling has the advantage that when you put the systems together, the complexity of the integration, the complexity of the interfaces is much lower, and therefore it's easier to debug the system as well. So minimal coupling is kind of a theoretical way of thinking about it that could, in theory, minimize the amount of work that's required in the integration process. In the real world, it can be difficult to apply this minimal coupling across the whole system, maybe within subsystems. So those are the 8 methods for integration. One other thing that should be mentioned is that what follows integration is the verification testing and validation testing. And those activities can and should be done as part of the integration testing. So in theory, you would integrate the pieces together and then pass them on to verification and then pass them on to validation. But there's no reason that when the integration testing is being conducted, that the verification testing can't piggyback or be done in parallel with integration testing. So whereas integration testing addresses the interfaces between the subsystems, the verification and then validation tests the behavior of the systems and the systems that are generated by system components. So with that, this is an opportunity to see what you know and take a little quiz on the integration process. It would be appropriate to pause the video at this point, get a pencil and paper, and to write out the answers to these questions. So this is a time to pause the video. And here are the solutions, answers to the quiz questions. I'd recommend to pause the video and to check your answers. Thank you so much for listening to this video. This was the integration process. The next video is the verification process. And if you like the video, if you could give us a thumbs up, we would much appreciate it. Thank you very much.